Okay, so last example for non-exact differential equation, solve 2y dx plus x minus x cubed y cubed dy is equal to 0. So first we need to find if this equation is a non-exact differential equation. So using test for exactness. So partial m with respect to partial y is equal to partial of 2y with respect to y. So partial of 2y with respect to y is equal to 2, and partial of n with respect to x is equal to partial of x minus x cubed y cubed with respect to x. So partial of x with respect to x, so this is equal to 1, minus partial of x cubed y cubed, so this is equal to 3x squared y cubed. So this equation is non-exact. So next step is to find the integrating factor. So case 1 and case 2 is not possible, so we try case number 3. So case number 3 is mn over y is equal to minus nn over x. Is it equal to partial of n with respect to x minus partial of n with respect to y. So if the terms at the left side of the equation are similar at the right side of the equation, then case 3 is possible. Okay, so m is 2y times n divided by y minus n is x minus x cubed y cubed, n divided by x. Is it equal to partial n is 1 minus partial of n with respect to y is equal to 3x squared y cubed minus 2. So cancel out y, so this is equal to 2n minus distribute n, so this is equal to mx minus, okay, distribute plus negative sign, so this is plus n x cubed y cubed with respect to x divided by x divided by x. So is this equal to 1 minus 2 is equal to negative 1. So minus 3x squared y cubed minus 1. We simplify further, so this is cancel out x, so this is equal to 2n minus n plus mx cubed, cancel out x and x, so this is x squared nx squared y cubed. This is equal to negative 3x squared y cubed minus 1. So we have said that if the terms at the left side of the equation are similar at the right side of the equation, this case is possible. So for the coefficient term, so the coefficient term is mx squared y cubed is equal to negative 3x squared y cubed. So we have a common terms of x squared y cubed and x squared y cubed. So we can now find the value of m. So m now will be equal to negative 3. Also, in a constant term, we have 2n minus 1 and negative 1. So 2n minus m is equal to negative 1. So since we find the value of n, which is negative 3, we can substitute m in this equation. So 2n minus 3 is equal to negative 1. So 2n negative times negative 3 is positive 3. Transpose it to the other side of the equation. So negative 1 minus 3 is equal to negative 4. So divide both sides by 2. So n is equal to negative 2. So we can now find the integrating factor as x is to negative 3 and y is to negative 2. So after finding out the integrating factor, multiply the integrating factor by the original differential equation. So we have now 2y dx plus x minus x cubed y cubed dy is equal to 0. Integrating factor is equal to x minus raised to negative 3 y raised to negative 2. So multiply. So this will become 2x raised to negative 3 y raised to negative 1 plus x raised to negative 2 y raised to negative 2 minus y dy is equal to 0. So after multiplying the integrating factor, we can now ready to test for exactness. So partial of m with respect to y is equal to 2x is to negative 3 y is to negative 1. Partial of 2x is to negative 3 y is to negative 1 with respect to y, treating x as constant. So this is equal to negative 2x is to negative 3 y is to negative 2. And partial of n with respect to x. So this is equal to partial of x is to negative 2, y is to negative 2 minus 1 divided by partial of x. So partial of x is to negative 2, y is to negative 2 with respect to x, treating y as constant. So this is equal to negative 2x raised to negative 3 y raised to negative 2. Partial of y with respect to x, treating y as constant, so this is 0. So the equation is now exact. So we are now ready to find the solution. So f xy is equal to c. So for solution, f is equal to the integral of n partial x plus f of y. So this is equal to the integral of 2x raised to negative 3 y raised to negative 1 partial x plus f of y. So this is equal to the integral of 2x raised to negative 3, 2x raised to negative 3 y raised to negative 1 partial x is equal to negative 1 over x squared y plus f of y. Okay, number 2. F is equal to the integral of n partial y plus g of x. So this is equal to the integral of x raised to negative 2 y raised to negative 2 minus 1 partial y plus g of x. So the integral of x raised to negative 2 y raised to negative 2 is equal to negative 1 divided by x squared y minus the integral of negative y partial y is equal to y squared divided by 2 plus g of x. So we have now a common term of negative 1 over x squared y and negative 1 over x squared y. Comparing 1 and 2, f of y now will be equal to negative y squared over 2 and g of x is equal to 0. Therefore, the solution is negative 1 divided by x squared y minus y squared over 2 is equal to C. Answer. So that's all, hoping that you understand the lesson. Thank you.